Hi everyone, Miss Millender here, and today we're going to talk about how you need to show your work, what you need to show in your calculations if you want to get full credit. All right, so the first thing is you need to show the original formula. So this is a formula like anything else, volume equals length times width times height, or density is mass over volume, or whatever, and you're going to have a formula sheet. So often it is just going there, finding the formula you need, and putting it on your sheet. There you've got it. However, there are some specific situations where you have to do some adjustments. The first situation is when there is no formula for whatever it is you're going to be doing. So what you have to do is design your own, which is actually not that hard. So let's look at one. If you were looking for the average diameter, you could indicate that by saying lowercase d with an average as the subscript. Then you're going to take the 5 diameters you know, add them together, and divide by 5. So there it is. That's a designed formula. There's no actual formula for figuring out averages. All right, so pretty clear. You'll have some practice doing that. The other situation is the formula has to be manipulated so that the unknown variable is by itself on the left side of the equation. All right, so what does that mean? Well, we're going to be talking about density, so let's look at the density formula. Here we've got it. So this formula is fine, and if you're trying to calculate the density, it's mass divided by volume, and you're good to go. However, what if you're given the density and the volume and you're asked to solve for mass? Well, I know that you know how to do this without manipulating the formula. However, in communicating to the reader of your work, you need to manipulate it so that the reader knows from the get-go what it is you're trying to solve for. So you would, and I'll show you how to do this in a minute, but you would manipulate that formula so it would read mass is equal to density times volume. It's the same formula, it's just manipulated so that now the m is by itself, and it's clear to the reader that the m is what you're going to solve for. So we have the formula that will solve for density, we have a formula that will solve for mass. What's left? Volume, exactly. So here is that same density formula, but it's manipulated to solve for V. So the volume is by itself, and it equals mass over density. And I'll show you how to do that in a few minutes. But let's stick with this average diameter problem for the moment. All right. So what you have to do after you have your formula is you have to substitute the numbers in with the units. Okay, so the variables go away, you put the numbers in. So here's that formula we designed on the previous slide. Now we're going to plug some numbers in. Well, I would get the numbers from a data table or something, probably a data table, maybe a graph, and so then I plug them in. So you can see here, I still have D average, but then I have my 5 diameters listed in the numerator of that fraction. Each one of them has a unit attached to it. And because there are 5 numbers, I'm going to divide it by 5. 5 does not count as a sig fig. And the reason for that is because it's a counted number. If you look at that formula, you can count that there are 1, 2, 3, 4, 5 numbers there. There is no uncertainty because you are absolutely sure there are 5. So counted numbers are not sig figs because there's no, I suppose there is a chance that you'd make a mistake, but generally speaking, when you count, you know how many you have exactly. There's no uncertainty. All right, so let's move on. So you have to substitute the numbers with the units into the variables. Please don't forget the units. You're going to lose points if you don't include the units. All right, so that's part 2. Step number 3 is to show the answer with the proper units and sig figs. So here's our formula. Here are our numbers substituted in for the variables. They have units on them. And we get this as the answer on the calculator, that the average diameter is 4.758 centimeters. Now we have to round to the correct number of sig figs. Well, we're adding, and if you look closely at all those diameters that are included in the equation above, they all are carried out or go out to the hundredths place. Every single one of them. So what that tells me, without doing a whole lot of underlining and figuring, is that my answer is going to have to be rounded to the hundredths place. So if you look at the answer that came out on the calculator, 4.758, the 8 will round the 5, so I'm going to change the 5 to a 6, and I get 4.76 centimeters as the answer. All right, awesome. So let's do another. So let's stick with Archimedes for a minute. So Archimedes knew the density of gold was 19.30 grams per milliliter. Grams per milliliter is the density unit that we will be using most often. There are others. This is the one we'll be using. Using water displacement, he determined the volume of the crown to be 85.6 milliliters. The question is, what was the mass of the crown? All right, word problems. There's a lot of word problems in here. So let's talk about how to approach a word problem. This is what I do. I read through and I get a sense of the story. Okay, the story is Archimedes knew the density of gold and he was able to determine the volume through displacement, so what's the mass? Pretty straightforward. Here's what I do. I go through the paragraph and I circle any of the numbers, any numbers that I run across, and identify them. I identify the variable that goes along with them. So 19.30 grams per milliliter, I know is a density because I recognize that unit of grams per milliliter. So I'm reading along and I'm reading along, and then I get to another number, 85.6 milliliters. So I recognize the unit milliliters as volume, but I could also go back into the reading, the volume of the crown to be 85.6. So I know that's a volume. I keep reading. What I do is I underline the thing that you don't know, the thing that you're going to be solving for. What was the mass of the crown? So again, I recognize that as the variable m, but I also know that I don't know what that is. So I just put the lowercase m and a question mark. So that's what I'm going to be solving for. So now I can look at this. I don't have to read it again. I can just look and say, all right, I have a density, I have a volume, and I'm looking for the mass. What formula do I have that has all three of those things in it? And yes, indeed, we have the density formula. But what's wrong with the way the formula is written right now? If you guessed that the m is not by itself on the left, then you got that correct. So we need to get the m by itself. In order to do that, we're going to multiply the right-hand side by v, but if you multiply the right, you got to multiply the left as well. On the right-hand side, the v's cancel. So I'm going to rewrite this so the m is on the left-hand side, and m is d times v. Mass is density times volume. Okay, so now let's follow the rules that we went through a minute ago. The formula must be manipulated so the unknown is by itself on the left side of the equation. We did that already, so that's what you're writing down for your formula. The next step is to substitute numbers in for the variables, making sure they have units on them. So here we go. The density I get from the problem, 19.30 grams per mil. And the volume, again, I also read it right off the problem, 85.6 milliliters. Then the third step is to show the answer with the proper units and sig figs. So I do out the math, and my calculator shows me 1,652.08. So I look back up at my original numbers. 19.30 has 4 sig figs. 85.6 has 3 sig figs. So I'm going to want 3 sig figs in my answer. I count over 1, 6, 5. So the 5 is going to be my last sig fig. But I can't just throw away the 2, the 0, and the 8. well, sort of, I can throw away the O and the A, but I have to put something in for that too. Otherwise, I'm going to round from 1,652 to 165, which doesn't make any sense at all. So you've got to put that 0 in as a placeholder. Notice, though, that there's no visible decimal place, so that 0 does not count as a sig fig. It's just holding the place. So you're going to have lots of practice with this, but make sure you show your work using these steps. Always, always, always. It is required. So you show all the steps, and you get 100% on all your calculations. If you show all the steps, and even if the number you get in the end is wrong, you'll still get lots of partial credit because you set it up right. And that's part of what you need to do. So, thanks for listening, and we'll see you later.